Okay, everybody, this is your math and measurement review for your test tomorrow. And so, like I said, I'll get this video out to you as soon as I could. And so, making this video at 4:15 this afternoon, and it'll be out to you, well, how about 4 to 5? All right, anyway, we're going to start off by saying, study this material, please. It'll make your life easy tomorrow. Give the SI units for the following. So basically the metric units for the following. That would be time, and that is going to be seconds. All right. Now for density, guys. Density is going to be grams per milliliter or grams per cubic centimeter. One of those two. All right. Length will be meters. Volume will be liters. And mass will be grams. All right. Below here, we're going to ask you to do some work with this, completing the equalities. To go from Kelvin to degrees Celsius, well, this one is 0 degrees Celsius. So in order to go from, from Kelvin to Celsius, degrees Celsius is going to minus 273. Anyway. 1 gram equals blank kilograms. If you do this properly, 1 gram happens to be 0.001 kilograms. 1 meter equals 100 centimeters. 1 kilometer is 1,000 meters. And 1 meter equals 1,000 millimeters. And if you remember, and this is in your notebook, you have this little metric ladder. It looks like this. 1, 2, 3, 4, 5. Hold on. 1, 2, 3, 4, 5, 6, 7. We got kilo up here. We got hecto, deca, the basic unit, which is going to be meter. That's not meter, that's reader. Let me fix that. That's going to be meter, liter, and gram for the basic unit. We have deci, centi, and milli at the bottom. That is 1,000 up here, 100, 10, 1, 0.1, 0.01, 0.001. Okay? All right, going to number 3. If a rock has a volume of 12 cubic centimeters, there's the volume, and a mass of 7.5 grams, what is the density of the rock? My advice to you is to underline what the volume is, what the mass is, and what you're trying to find. You're trying to find density. Density equals mass divided by volume. So the mass is going to be 7.5 grams. The volume is going to be 12 cubic centimeters. And calculate this out. My calculator out here. 7.5 divided by 12 is 0.625 grams per cubic centimeter. Those are your units. Please box your answers. Now, if you don't want to use that formula, density equals mass divided by volume, you can use that density triangle. You also have the reference sheets that you have today. Those are yours to keep all year long. So we have here density, we've got volume, we've got mass up here, and we've got multiplication there, division there, and division there. Okay, we'll have that on the board for you tomorrow while you're taking your test. Okay, here we go. Number 4. The density of copper is 8.96 grams per cubic centimeter. So there's the density already. What is the mass of a piece of copper? So you're trying to find mass that has a volume of 1.34 centimeters. So we're trying to find mass. We were given the volume, and we were given the density. So the mass is going to equal, if you look at your density triangle, mass is going to equal density times volume, which means the density is 8.96 grams per cubic centimeter times 1.34 cubic centimeters. And when you solve for that, 8.96 times 1.3, we get 11.648 grams. And you'll know what you're going to round to on a test tomorrow because it's multiple choice anyway. So you'll find the answer, it will not be a problem. Okay, let's go to number 5. Nope, next page. All right. An 11-gram object was placed in a 50 milliliter graduated cylinder containing 35 milliliters of water. The final volume was read as 48.4 milliliters. What is the density of the object? Okay, so we got to find density, right? We have a mass here, 11 grams. We don't know what the volume is, but we have water again. So if you remember from today, to find the volume of that, we're going to take the final volume that was read, subtract from that the initial volume that was read, and then it'll give us our volume of the object, which that would be, the final volume is going to be 48.4 milliliters. Subtract from that 35 milliliters, so 48.4 minus 35 equals 13.4. So that equals 13.4 milliliters for the volume of that object. So now we can calculate the density because we have the volume now. It's right here. So density equals mass divided by volume. The mass is 11 grams. The volume is 13.4 milliliters. So 11 divided by 13.4, 11 divided by 13.4 gives me 0.820 or 821 grams per milliliter. And just box our answers again. Okay, scientific notation stuff. Here we are. It's not too hard, just moving a decimal. So here we go. A couple examples from today. We're going to change 0.000034 to scientific notation. Well, taking that decimal, it has to go between the first two non-zero digits. So it's 3.4, the decimal's going to go there. We put the times 10, which is necessary for scientific notation. And this is a number less than 1, so your exponent is going to be negative. And so how many spaces away? 1, 2, 3, 4, 5. Negative 5. Oops, let me fix that, make it look more like a 5. Negative 5. 2,000.4 milliliters. What is that? Well, the decimal is going to end up right here. And that's going to be 2.0004, got to include the last number, times 10, which you need to have, and that is 1, 2, 3 spaces away, times 10 to the third. 302.05, that would be 3.0205 times 10, always put that in there, and we put that decimal right there to make a scientific notation, right? How many spaces away? 1, 2, times 10 to the second. Okay, so far so good. Now we have a number that we're going to put in scientific notation that's less than 1. So our exponent will be negative. Anyway, the decimal will go right there. So we start with 5.70 times 10 to the minus 1, 2, 3, to the minus 3. And 70,000 milliliters. The decimal's going to go right there. It'll be 7.0 times 10 to the 1, 2, 3, 4 times 10 to the fourth. And there is your scientific notation for number 6. Number 7. Solve the following using dimensional analysis. Show your work and make sure that you box your answers. Here we go. All right. We're converting 74.5 kilometers to meters. So what we start with, 74.5 kilometers, km, and we're going to meters at the other end. The conversion for this is that 1 kilometer equals 1,000 meters. So we're going to put 1 kilometer down here because whatever unit you have in the upper left, you got to have down the lower right. That's this part of the equation of the conversion factor. And the other part is 1,000 meters, and that's going to go on top. And if we cross off our units here, we're left with the meters like this is what we want. And so that's 74.5 times 1,000. And if you don't know how that is in your head, 74.5 times 1,000 equals 74,500 meters. And you box your answer. Converting 3,644 centiliters to liters. The conversion for that is that 1 liter equals 100 centiliters. So let's write down what we know. We have 3,644 centiliters, and we're going to convert that to liters. So here's the conversion factor. If we have centiliter right there, then centiliter is going to go down here, and that's going to be 100, and the liter goes on top. There you are. So this becomes a division problem. When you see the number down there in the denominator, that's other than 1, and that's we have 100 right there. So it's 3,644 divided by 100. And 3644 divided by 100, 36.44 liters. All right? There's your answer, and box the answers. How many inches in 2.6 times 10 to the 4th miles? Okay. Well, this one's not so bad. It has some conversion factors we got to have with this. We got to use. We're starting with this, miles here. And so here's our conversion factors. We want to get to inches. We want to know inches. But we start with miles. Well, I'm going to give you some conversion factors here. 1 mile equals 5,280 feet. That's one conversion factor. Another one is 1 foot equals 12 inches. And that should be good enough. Oops, we'll put a foot right there. There we go. A T right there. That should be good enough to get us where we need to go. Okay, but we need to take this one, this number, and make it a regular standard number. Standard notation is what we call it. So here's what we do. We're going to write down, we're going to write 2.6, and that little exponent, this 4, is going to tell us to move the decimal 4 spaces to the right. 1, 2, 3, 4. Fill in those spaces with zeros, and our new number is 26,000. So now we can start with 26,000 miles, right there. Do our railroad tracks. All right, miles is going to go down here because we started with it. So the conversion that has that in there is 1 mile equals 5,280 feet. And we're going to do it again. We're going to put feet down here, and we'll put 1 foot right there, and the other part of that is 12 inches, so we'll put 12 inches on top, okay? Now solve for that. That's easy to do. It's a multiplication problem with the numbers going all the way across the top. And what we get is 26,000 times 5,280 times 12. There we go. Let's try that one more time, make sure I get my number right. 26,000 times 5,280 times 12. That's going to be a number like this. 1,647,360,000. 1,647,360,000 miles. In scientific notation, that is 1.64736 times 10 to the 9th. And both answers for that are good, but the units are also inches for all of them. Okay? That's how we solve that problem. And if we make sure we have our units right, we can cross them off and see what we have left. We have inches left, and that works out. Now the last one for this test, describe the difference between qualitative, quantitative data. Qualitative. And make it simple. That has to do with a quality. Quality, if I can spell right. Quality. A description. Example, gray clouds. Okay, we have a quality, a description. We have red shoes. We have a quality. Now, we can say tall students. A quality, tall, okay? Now, if you want to take that and talk about quantitative, quantitative has to deal with numbers, a quantity, an amount, all right? So, trying to get pistachio. Okay, examples for that. 4 people, a quantity. 8 chairs, a quantity. Okay, so that's how you can make a distinction between the two. And that's it. That's your review for tomorrow's test. Bring this review for extra points tomorrow. Okay, bring this review for extra points tomorrow. Study your material. Good luck. And after this, if you have comments or questions that you're putting into the questions or comments section, I will answer them for you. In any case, have a good night.